This is the 15th of October 2013. We're at Vincent Corporation in Tampa, Florida. We're going to run some tests. This is a press ready for shipment. We're going to run a test in a press like this, a little 4-inch press. We've got it set up over here. The material we're going to run is from F&C in Israel. It is licorice fiber. Not real optimistic on what results we'll get when I take a sample of this material and squeeze it. Okay, I'm getting a little water to run out between my fingers. We ought to be able to get that out, but not that much more. Because of this, I'm setting the air pressure on the regulator at 45 psi, 3 bar, a little bit on the high side for this press. The air cylinder with that air pressure will push this bronze cone or door shut. The press will have to work to overcome that force to get the cake out. It means it has to squeeze the material harder before cake is produced. This one, this press, we used it on avocado stuff the other day, so it's set up for steam injection. That is, we've got a boiler right here, and we injected steam into the press. I've got samples of from the top of the pail and the middle of the pail, and we'll get the bottom of the pail. Speaking of this pail right here. Here we are checking the slot width. It is 15 thousandths to 18 thousandths. That'd be 350 microns to 480 microns, something like that. Pretty narrow slot width. You can see it on the inside here. That's the inside slot width of the screen. The press liquor will come through this. We're going to run this press with a VFD. We've got a variable frequency controller and inverter to cut down the speed, give us a little more residence time. The longer the material sits in the press, the more time there is for liquid to drain out. I see the flighting on this press. Notice that hard surfacing on the end of the flight there. That is weld-applied hard surfacing designed for abrasion resistant long term. Certainly no need for it in a lab press, but somebody got carried away. Okay, Bill's feeding some material in. I've still got the cone open here, air cylinder in the retracted position. And the inlet hopper. There's the screw. You can see the material being fed. Not bridging badly or anything. Normally we expect bridging in this press. That is, it's got an 8-inch opening at the top but a 4-inch screw, so it tapers down. We wouldn't do that in a bigger press. Okay, here's some material coming out already. So I'm going to go over here, and yep, it's still set at 3 bar, and you'll see the cone go shut. So that gives us back pressure. We also, right away I see some drops of press liquor coming out. Good sign. The other way we're getting compression in this screw press is with tightening the pitch of the flights. I'll probably be able to show you a screw later on to show you know what that means. What we would do in a larger scale press on this material is taper the shaft to squeeze material out against the screen. Bill's breaking a bridge right there. And we'll see what happens. Material is making its way towards the discharge end. I see some fines coming through. Normally with press liquor, yes, you'll get fines coming through. And so the press liquor, what we're looking at here, would be filtered through another screen, maybe just a simple static gravity side hill screen. Then the solids, the fiber that you filter out of the press liquor, you put right back inside the press with the regular material. We're not getting any cake yet. That is, we're still filling up this press. We're starting to get some liquid out here. That is, the material that's going to be coming out has not been squeezed. It was simply conveyed whereas the material in here now is being squeezed. So the first cake always comes out wet, then we get a dry cake. You can see the cone opening slightly there. Anise, that was what it was in Spanish. The horses like to eat it. It was a weed that grew. And I heard that if you fed it to rabbits, it would kill them. Rabbits weren't supposed to be fed anise, licorice. Okay, the cake is, the cone opened, I'd say, on the high side. It's a long travel. And you can see the wet material was the first coming out, and now this white color is drier material. We're still getting press liquor. The screw is running very slowly. I cut it down to 30 hertz. I'm going to increase that to 60. I don't see any reason not to go for higher throughput capacity. Okay, we're running full speed on this press, 28 RPM. Starting a test, time test. This is what came out originally. Now we're going into a fresh pail, fresh container for a time test. Throughput capacity isn't as high as I would like it. If we build a regular press for this, we'd want to be sure to have single pitch sliding as opposed to 2/3 or 1/2. That is, this material has the bulk density. It looked thick to me, but it must be relatively low for the capacity. We're not feeding it into the press as fast as I would like. Okay, this is looking more like it. I'm surprised we're getting this much liquid out of this material. And cake not coming out as fast as I'd like it, but still, when I see this much liquid coming through the screen at that rate, yes, this is an application for a screw press. I took a bricks reading, and it might be 1 degree bricks, almost no dissolved solids in this material. pH is real close to neutral, as much as we can read. So nothing exciting there. Okay, we're clearing the press. That is, we've got the cone open. We're going to start a second test at lower pressure, 1 bar instead of 3 bar. We'll keep the same 28 RPM on the screw. Here's a couple of screw presses. There's another. Here's another. Screens, a variety of screens for presses. Another press. There's a press on a stand ready to ship. There's a larger machine. We've been sandblasting, and you see screw presses all over the place here. These are from in a dewatering screen. This is the staging area. Anything that comes back, we park here until we're ready to do something with it. Okay, we're into our second time test at 1 bar. The cake looks darker brown to me, which tells me it must have a higher moisture content. We're still squeezing plenty of liquid out. This is carrageenan. We are testing a shredder, Vincent shredder. Carrageenan is made from seaweed. Sample was sent up from Israel last week. Not Israel, from Chile last week. We're 9 minutes into our test. The cake seems to come out intermittently like a knots press, like we were doing knots from knot holes. And the press liquor does the same thing. It'll come out in surges, looks real good. Then other times it's weak like this, like we had excessive slippage going on inside this press. Also, the press liquors come out, it usually happens this way ahead of the resistor teeth. We've got resistor teeth here. But usually we get some liquid through the screen, and we have it on this other side. So this material is different. It's going to take some thinking to figure out how we would configure a larger press. Yeah, liquid's coming out again, and cake pouring out. Strange, we didn't do anything. That'll be the configuration of the screw. We think this material that we received is consistent, not wet spots and dry spots. This is Thursday, 17th of October, 2 days later. We've rehydrated the material. That is, we took all our cake and all our press liquor, mixed them up. Hard to mix them up, but we did. And we're running a test here. We've modified the screw in the press to see if anything comes out any differently. I'll be running the test now at 2 bar, 30 psi. We're just filling the press for the first time. Still no liquid. We didn't get liquid over here last time. We'll see if that continues. We're 3 minutes into this test. It'll be labeled test number 3. Notice I'm still getting some liquid out here. Cake's coming out. Main thing is we've had a steady flow of press liquid. It hasn't surged once. Suspect we're getting more throughput capacity, and all this was due to filling the notches and grinding smooth the hard surfacing. The hard surfacing was tungsten carbide, which is almost impossible to grind, but we did our best to smooth it out. This resistor bar, I noticed had square teeth, which is unusual. Standard is round. All our previous performance testing is with round teeth. Shouldn't make any difference, but we're on test number 4. There you can see the square teeth. They were drilled out for steam injection. This is test number 4. Those teeth weren't square. They were simply rounded off. They apparently ran into the flights of the screw, and we had ground one edge flat. On this 4th test, liquid looks about the same. Plenty of cake coming out. We'll start our time test. We're tests are only 5 minutes long this time. This is a typical screw. The inlet hopper is right in here. We'll repeat the material in to the first stage of compression, second stage, third stage, fourth stage, fifth stage of compression. Those teeth that we've been looking at go between in these gaps, like right in here, or right in here, right in there. This screw has a tapered shaft, gets additional compression. Here's one with a taper just at the end, and we make lots and lots of screws for screw presses. Here are a pair of screens. This is a wedge wire screen. Gap looks wide on the outside, but on the inside you can see we're down at 400 microns. Another type of screen is perforated, and here you see little tiny holes. Those are about 550 micron diameter. That's as small a hole as we go. This 3/8 hole, the big hole, is a reinforcing material. This is a static screen. We pump the press liquor into this compartment back here through that hole back there. It overflows this weir and down the face of this screen. Typically about 1 millimeter slots. These look bigger or smaller than that, maybe a half a millimeter. The solids fall off down here at this end and go on into a screw press. Anyway, this has many names: a static screen, side L screen. It's used to take the fiber out of the press liquor and drop it right back into the screw press that it came from. These are explosion-proof presses. You can tell because the covers are tight. That one has a Pyrex window with a windshield wiper. These are used for testing. We make them ATEX approved, the European standard for explosion-proof. This is one of the largest or longest lathes in the state of Florida. We're turning the OD of a screw. That white material is material catch weld splatter, so it don't stick to the shaft. And as you can see, this is a very long lathe. I mentioned filling in notches. These notches catch fiber, and they work like a brush. As the screw goes around, the fiber stuck in those notches wipes the screen clear. Yeah, I had those filled in the 4-inch press for the test number 3 and 4. There's another tapered shaft screw. The hard surfacing, once you know I found one without hard surfacing. Okay, hard surfacing is weld applied, especially to the edge of the flight. And This one has a lot of hard surfacing on it. I had that ground smooth because in a 4-inch lap press we shouldn't have hard surfacing. This is the assembly department. I believe this is the press we saw the other day. Here's one that came back from Tropicana, which is Pepsi-Cola for rebuilding. This one's back from a paper mill. It's in our rental fleet. They finished their testing. And we're in the assembly department, where you see lots and lots of frames for lots and lots of presses and assembly. These presses all being assembled in the background here. This is the frame for a screen of a 30-inch press, and this is the reinforcing plate that goes on the inside. It's used by a plastic recycler. Here's a screen that's been fabricated. You can see the green is carbon steel painted. It's a perforated screen. Fairly large holes in there, probably 2 millimeter, and it'll be down here for machining some grooves that index it so it's positioned around the centered around the screw of the press. These are Golden Phoenix roosters, and this is a test to see if anyone actually watches this video to the end.